Okay, then we can start. So last time we were discussing about the critical path method, and in the critical path method, we started from the activity on arrow diagramming method. So can you hear me?
Yes, we hear it.
Yes.
Okay, great. So if you have any question, then you can just you can interrupt me anytime, or even you can write the message in the chat box. So we were here last time. So we have said that we can draw an activity on arrow diagram. So suppose we have the information about the activities and their precedence relationships. By precedence relationships, I mean which activity precede which other activity. So for example, this activity, let me display these arrow options is visible. Okay, so let me by the precedence relationship, what I mean is that, for example, this drill well precedes this pump house activity. Okay, drill well activity precedes this pump house activity. So using these precedence relationships, we can develop this activity on arrow network diagram. Okay, so once you establish this activity on arrow network diagram, then the next step to complete the network is to perform calculations. So the calculations will be performed to calculate the activity start and finish times, and also the event start and finish time. So event start time, event finish time, for example, in this network. So for this to happen, you will perform the calculations, okay? So event time calculations, event time calculations. So there is the text about these event time calculations, which is there in these slides. But what I can show you is on this diagram, how these event time calculations have been performed. So if you see that this is the same diagram which have been shown, but now there are some additional numbers shown on these diagrams. And how these additional numbers have been calculated? So for the calculation of these additional numbers, we will start from the left of this diagram. Okay, from the leftmost event is event number 1. So therefore, it is also important to have the event numbers appropriately. So the event number should increase from left to right. Okay, so 1, 2, 3, 4. So it is so that we can easily identify which is the earliest most event in the network. So in this case, this event number 1, which is shown in this circle, is the earliest most event. So we will start from 0 over here. 0 over shows the starting time. 0 shows the starting time. So if this event starts at 0, that means now, and then that means event start time is now, then it will be followed by an activity drill well, which will take like 4 weeks. Okay, so 0 plus 4, then that activity will finish at the end of 4 weeks. But we will show it as an event finish time. Okay, so the finishing of that activity is the finishing event of that activity. So 0 plus 4, that is 4. 4 is shown over here. In this diagram, for clarification, these numbers, event time numbers, have been shown with the bar under the number, which is optional. It is up to you. So these bars have been shown over here to distinguish them from other numbers. So for example, this 4 and this 4, the difference is that this 4 is the duration of the activity, 4 weeks. And this 4 is the ending event time for activity D. Okay. So This is the event time for activity 2. So for the drill well, okay. Okay, next we have, because from here we see that 4 activities are starting. So therefore, for each of these, we can have this event time over here. For example, for this number 5, 7 is shown because this 5 depends on these 3 different activities, okay? Pump house, construct power line, and this excavate, and which is connected with this dummy activity. Okay, so it is better to calculate 5 later on. So first calculate number 4, okay, event time for the event number 4. This, which will be 5, which is simply 0 plus 5 is equal to 5, because there is only one activity leading into that event. So therefore it will be 5. Okay, so now once we have calculated 5 over here, now we can calculate the event time for this event number 5, which is 7. 7 is the maximum of these 3 event times, which we can get from these 3 different paths. So for example, from this path, drill well and pump house, we can get a time of like 4 from here and plus 3, 7, okay? And then directly from this event number 1 to event number 5, we get 1 plus 3, only 3 over here. And from 0, 1, 4, we get 5. And then because since this is dash line is the dummy activity, so we get 5. So therefore, these numbers 7, 3, and 5 in parentheses have been shown to distinguish them from these 2 other numbers, because these parentheses numbers are just for our reference only. The final number which we will take over here, from here it will be 7. So why do we have to take the highest number? Because if we take any number lower than this, the other activities will not have been completed. So therefore, this event number 5 have to wait to complete all the activities preceding this activity. So therefore, we will take a number equal to 7 over here. Okay. So now we have decided 7, 5, 4, these 4 numbers. This number 2 is obvious, which is 2, 0 plus 2, which we have over here. And then we have for this event number 6. So you can see that we have a number 9, which is the highest of the 2 numbers. 5 plus 4, which is 9, and then 2 plus 4, which is 6. So from 6 and 9, 9 is the highest number. Although it has these 2 options for clarification purpose have not been shown over here, but you can easily see that 9 will be the highest number which we will take. So now this last event number 7, so we will take a value of 15. Why? So 7 plus 2 is 9, okay? 5 plus 6 is 11, but 9 plus 6 is 15. So out of 9, 11, and 15, we will take the highest number, which will be 15. Okay. So is it clear? Then how did we get these numbers with these bars under these numbers? See, these are the event times. Any question about this?
Those numbers are days or weeks?
Well, weeks. Okay, I mean,
okay.
I may have said days, something like this, but because I'm more used to of saying days. So we have to be very consistent, okay? We have to be very consistent. So if we are using weeks as the unit, so we should use weeks. If we are using days as a unit for the time, so we should throughout use days. Okay, weeks is more appropriate over here because of the size of the project which we can imagine. So do you have any doubt about how the calculations have been performed? It is simple. So for those events where more than where two or more activities are going into, such as this number 5, number 6, and number 7. So you will take highest of the highest of those preceding values. Okay, so this is the only thing which you need to remember. Okay. Any other confusion? Okay, so after doing this calculation, so this type of calculation is called as the forward pass calculation. Forward pass calculation. So this forward pass calculation calculates the earliest and the latest time for the events. Okay, that the this sorry. I should say again, this forward pass calculation calculates the earliest and the latest earliest start time and the latest finish time for the activity. Okay, remember that earliest start is represented by EF and latest finish is the latest finish time for the activity. Okay, so we have, for in this case, although we have calculated those events time, so we can say that this activity drill well can start as early as the start of the project and can finish as late as 4 weeks. Okay. Similarly, for pump house activity, we can say that this activity can start as early as 4th week, but can finish as late as 7th week. Okay, this is obvious because there is no no freedom in this activity. I mean, cannot start more in any other day without delaying this project. But for this activity 3, we can say that we can see that this activity 3, this activity construct power line needs only 3 weeks to complete. But it needs only 3 weeks to complete. But it can start anywhere between 0 and 7 weeks because the start and finish of this activity depends on these events 1 and 5. Okay, so this activity has the freedom of 4 days. Okay, so for example, if it starts at 0 weeks, then it can finish at the end of 3 weeks. Okay, but for the next 4 weeks, then there is no work available. So this means that this activity can start even later than that. Okay, so therefore the meaning of these event times is that these event times show the earliest start and latest finish of each activity. Okay, so this will earliest start and latest finish. So this you can say that earliest start is represented by, say, E F, and the latest finish is represented by LF. Okay, if there is earliest start, sorry, it should be earliest start. Okay. Okay, if there is an earliest start of an activity, then there should be earliest finish of that activity as well. Okay. And if there is a latest finish of an activity, then there should be latest start of an activity as well. This is there is some problem. Like, latest start. Okay, so latest start, latest finish. But what we can calculate is earliest start from this network and latest finish from this network. Okay, so but this So this network, with this network, as I have said, that I can calculate the earliest start and latest finish. The other two times we can very easily calculate it. If now we know the earliest start of each activity, okay, we can calculate the earliest finish of this activity by just adding the duration of the activity. Do you understand?
Yes.
Yeah, if you just add the duration of the activity, then you can calculate the earliest start of the activity. So for example, this construct power line, earliest start of the activity is 0 from this diagram. But what will be the earliest finish of this construct power line? It will be 0 plus 3, that will be 3 days. So therefore, we just need to add the, what you say is the duration, okay? So we just need to add the duration into the earliest start, then you will get the earliest finish, okay? Now, so we know the latest finish of the activity from this network. So for example, the latest finish of this construct power line activity is 7, okay? Which is the same as the for pump house and for excavate activity as well. But from latest finish, if we want to calculate the latest start of this activity, what we need to do is, by this analogy, can someone tell me?
So from latest finish, we can take out the duration of the event.
Yes. So we can subtract the duration. So latest finish minus the duration, which we can represent by D, and then it will be the latest start of the activity. So this, in a very conceptual way, you can establish these duration times. Okay, so and later on in the slides, I think these formulas are given over here. But okay, so this what we
can you clarify one thing, just not to be confused for them all? So latest finish of one event is the early start of the next event, right?
Yes.
Okay.
Yeah. Yeah. For what? Actually we do not establish much about the two event times, otherwise it will become very confusing. So event times, we take only one number. For the event times, like the one shown over here, we just take one numbers, okay? So for example, this 0 over here is the latest earliest start of these 4 activities. This 2 over here is the this number 4 over here is the earliest, the latest finish of activity drill well, but it is also the earliest start of pump house. Okay, so it can be a quiz question actually, right? But anyway, so for these calculations, we can just assume that we can just say that very safely that earliest start, and this that means this activity on arrow diagram just tells us about the earliest start and latest finish time of each activity. We are more actually, for our purpose, activity times are more useful. Okay, so that's why we immediately focused into calculating the activity times from the event times. Okay, so this was the forward pass calculation. But so this what this forward pass calculation has determined is that it will take 15 days to complete all activities. 15 weeks to take all activities. Okay, this in another way is to say that this project, which is represented by this network, will take 15 weeks to complete. Okay, so therefore, by forward pass calculation, we can calculate the minimum duration of the project. We can calculate the minimum duration of the project. By minimum duration, the meaning is that by the available information, by the information which we input into this network, that is the minimum duration of the project. Well, of course, if we, for example, for certain activities, if you decrease the duration of the project, we can further decrease the duration of the project. We don't mean like that. We mean that by the minimum duration of the project, we mean that by the available information, by the information which we input into the network, that is the minimum possible duration that the project can be completed. So in this case, the minimum possible duration that the project can be completed is 15 weeks. So forward pass calculations determines the duration of the project. Okay. So in this case, then we have determined the duration of the project, and if we want to calculate the duration of the project, what we have done over here is that after that, what we will do is the calculations, and we can perform some more calculations. Okay. We can perform some more calculation, and these those calculations will be the backward pass calculations. Okay, backward pass calculations. Okay, so after performing the forward pass calculation, we can perform the backward pass calculation. And now you can see that some of the numbers have also, some additional numbers have been shown over here. Okay, some additional numbers have been shown over here. So what these additional numbers show? So in the backward pass calculations, these additional numbers show some extra time. These additional numbers show the events for those the how late an event can occur over here. Okay, so for example, if you see that where we finished last time.
Sorry?
We finished last time over here, right?
Yes.
Yes, over here. I mean, in the previous slide, we finished over here. Okay, so then what we have over here is this network. Okay, and this network is showing us some additional numbers. So you can see that now, in addition to this 15, we have some numbers over here, and those that means under the circle we have some numbers over here. Okay, so how these numbers have been calculated? These numbers have been calculated by performing calculations backward. Okay, so in this last picture, when we performed the forward pass calculations, we reached from this number. From here, now we will go backward. We will go backward. So we have determined that it will take 15 weeks to complete. So if we suppose that the project is going to take 15 weeks, that means this event can finish as late as week 15. As late as week 15. Okay. So if this event can finish as late as week 15, and then this activity, now we are moving towards the activity. So 15 minus 6, that will be 9. 15 minus 6, that will be 9. So this will mean that this event number 6 can start as late as week 9. Okay, as that is week 9. So therefore, we have represented this number 9 over here. Okay, and to distinguish it from the previous numbers, we are putting a bar above the number over here. Okay, so this is just for the clarity. Okay, so that's why it is shown as EET is the earliest event time, LET is the latest event time. Okay, so 9 bar over here. How this number 5 was obtained? So this 15 minus 6 is 9. Okay, 15 minus 6 is 9, because here we can see that for this event, three tails are meeting over here. Okay, one tail is from this install pump. Okay, through this dummy activity. The other tail is from this install pipe, and the another tail is from this foundation. So there should be 3 times, and we will take the lowest of these 3 points over here for this event. So from here we have 15 minus 2 is 13, and 15 minus 6 is 9, and 15 sorry, not from here, it will start from here. 9 minus 4 is 5. So out of 13, 9 and 5, we will take 5, the lowest value. So remember that when we are doing this backward pass calculation, earlier we were doing the forward pass calculations. In the backward pass calculations, we will take the lowest of the 3 or more, or 2 or more times. Okay, so 13, 9 and 5, we will take 5 over here. Okay, and for this, if it was 7 over here, but for the latest time, 15 minus 2 is 13. So this is the only tail of the arrow which is over here. So we will take 13 over here. So the latest event time will be 13. Latest event time will be 13. And then from here, only one tail of the arrow. So 13 minus 3, it is 10. Okay. And for here, event number 3, it will be 9 minus 4, it will be 5. And now for this event number 1. So there are 4 tails over here. So one of them will be 10 minus 4 is 6. Okay. Another one will be 13 minus 3 is 10. And this will be 5 minus 5 is 0. And then this will be 5 minus 2 is 3. So out of these 6, 10, 0, and 3, we will take 0, the lowest value. So in this way, then we have calculated the earliest event time and the latest event time. Okay, so can you tell me how did, in which process we calculated the earliest event time? Is it the forward pass or backward pass?
Forward pass.
Yes, in the forward pass, we calculated the earliest event times. In the backward pass, we calculated the latest event time. Okay, so with this, we have almost completed the network calculation on the activity on arrow diagramming method. Okay, it is called as the AOA. So we have almost completed the activity on arrow diagramming method calculations. So what this backward pass has given us is that in the forward pass, we have calculated most of the things actually. But in the backward pass, we have additionally calculated the latest event time. So latest event time in addition give us some more information about those events which have the same EET as LET, or which have the different EET and LET. So you can see that for event number 1, EET and LET are same. For event number 4, EET and LET are same. Similarly, for event number 7, it is same, right? And from here, we can see that we can distinguish those activities as well. Okay, so what will be those activities? So for example, if we say go from here to here and then there, that will give us the longest path. So for example, 5 plus 4, 9, plus 6 is 15. And then this is 5 plus 6 is 11. So there will be a longest path in the network, okay, by which we can say that that path will be the critical path. So this is shown in the next diagram over here. As you can see, yes.
Sorry, just to clarify one more time. So second event, which is pumping house. So second activity, I mean, so it can start even though it takes even though it can start after 4th week, it can be started also after 10th week, right? So it will be in duration.
Pump house.
Is that the meaning of the
no. Pump house is for example, because for this pump house, yes, because for this pump house, you can say that its earliest event times are 4 and 7, but its latest event times are 10 and 13. So pump house can start
in between 4 and 10, right?
Yes.
Thanks.
Yeah.
Professor, I cannot understand. In the 7th event, why the earliest time is EET is 15? So isn't it 11, like after the excavated install pipe? So
Install pipe.
We should, yep. So look,
we should take the highest value. We should take the highest of the 3 values. So for example, one value is 7 plus 2 is 9, and one value is 9. Okay. And the another value is 5 plus 6, 11. And the third value is 9 plus 6 is 15. So we have to take the highest.
So for
highest
EET, we should have the highest value, but in LET we should have minimum value. Yep.
The lowest value. Correct.
The lowest. Yep. Okay.
Correct. Okay. Yes. So with this, then we can see that there are certain events which we can. There are certain activities which we can identify as the critical activity. So excavate is the critical activity, because you can see that for this excavate, we have it is connected by 2 events which are critical. Similarly, foundation is a critical activity. Okay, foundation is a critical activity. And erect tower and tank is a critical activity. Okay. So
And one more question. So for LET we should calculate backward, and for EET forward. Yep.
correct. So first we will calculate the EET, earliest event times, by the forward pass calculations. And after completing the forward pass calculations, we will calculate the we will do the backward pass calculation, which will calculate the earliest event times. Correct. Okay. So I think to identify this critical activity, it will be better to use these formulae. Okay. So for example, the earliest start time is the earliest event time of the preceding event. Okay. And then the earliest finish time is the earliest start time, that is from previous, plus the activity duration. And the latest finish time is the latest event time of the following event. Okay. And then latest start time is the latest finish minus the activity duration. And then we can calculate the total float, which will be for the activities, which will, that is equal to the latest finish minus earliest finished, or in another way, we can also calculate the total float by the latest start minus the earliest start. And this can be represented in the form of the table. Okay. Actually, it is better for me if I can do it on some board or like that, but probably I will later on, I will show you some tutorial examples. In that I will do it live. But the thing is that if we want to establish this table, so you know that you already know the you have this information like activity numbers from the, so this information you will have it, right? Activity numbers. and the description of the activities and the duration of the activities which you will have. Okay, so remember that the earliest start time you can calculate from the forward pass. Okay, so from the forward pass you can calculate the earliest start time, and the latest finish time you can also calculate from the forward pass. So those earliest event times which you calculated, those earliest event times which you calculated will give you these values. And then from the earliest start time, you can calculate the earliest finish time, but by simply adding 4 into that. Okay, 0 plus 4 is 4. And it's, if you calculated the latest finish time, which was 10, so if you will subtract 10 minus 4 is 6. So this is just plus duration. And then this is just minus the duration from here. And then this is just plus the duration from, okay, from here. So this is how you can complete this table. So this is the activity time schedule table. By this you can very easily calculate after the time. So after that, after you calculate it, then you can calculate the total float. Okay, so total float is what? Total float for each activity. Total float for each activity will be the, it will be equal to the 6 minus 0. That is the late start minus early start, or late finish minus early finish. So 6 minus 0 is 6. 10 minus 4 is 6. Okay. Here it will be 3 because late start 3 minus 0 is 3. 5 minus 2 is 3. So it can, you can either use the LS minus ES formula or LF minus EF formula to calculate the total float. So then what is the total float? So you can see that if you will calculate the total float, some of the total floats will be 0. So those, for those activities for which the total float will be 0, those activities will be the critical activity. So once you calculate these total, once you identify those activities, in this case, excavate, foundation, and the erect power and tank, then you can represent those activities, critical activities, on the activity on arrow diagram. Okay. Remember that you can better identify the critical activities from those total float calculations. If, for example, if you see that if you say that install pipe is a critical activity because its starting event has both LEET and EEF as same, and finishing event has also EEF and EES are same, then I think it will be wrong to calculate it, because in this case, if you will see that it has its float is not the same as we have calculated, is not 0. So the float for only these 3 activities is 0 over here. Okay. So for those activities for which the total float is 0 will be the critical activities. And these critical activities have been shown by the double arrow in this diagram. Okay. Okay, so then one question is that what is the float? So float is the time by which an activity can be delayed without delaying the project. Okay, so if the float is say 1 day, so it means that that activity can be delayed by 1 day and it will not further delay the project. So for example, we have calculated for a drill well, we calculated a float of 6 days. As I can see over here, for drill well, we calculated a float of 6 days because its earliest start time was 4, its latest start time was 6. So it means that although it can start as early as 0, but it can start as late as 6 weeks without delaying the project. And this we can also see from this diagram as well. So suppose if it is instead of 0, if instead of 0, it is 6. So it will be 6 plus 4 is 10. So this value will be 10. And then 10 plus 3, it will be 13. And then 13 plus 2, it will be 15. So it means the last duration, the last time over here, the last event time will not change in this case. Okay, so it means that is the total float in this path. Similarly, the total float for construct power line was calculated as, for the construct power line, where was that? Yeah, it was 1.5. It was 10. Yeah, it was 10. So see that if it is 10, so for it was 10. So suppose it starts at 10, so it will finish at 10 plus 3 is 13, and 13 plus 2 is 15. So it will not delay the project. So therefore, float is the time by which we can delay the project without delaying the overall duration of the project. Okay. But however, for this excavate activity, if, for example, if I say, if instead of starting at say 0, I start at 5 weeks later, okay, so it will be 5 plus 5, that will be 10, right? So it will be 10 over here, okay. So it will, if it is 10 over here, then if it is 10 over here, then it will be 10 over here. Okay, if it will be 10 over here, it will be 10 over here, but that doesn't make any difference. But from 10 over here, if I add, I have to add 10 plus 4, that will be 14. 10 plus 4, it will become 14 over here, and then 14 plus 6, it will be 20. So instead of 15, we will get a number equal to 20 over here. So excavate activity cannot be delayed. Similarly, foundation activity cannot be delayed, and then erect tower and tank activity cannot be delayed. So that's why these activities are called as the critical activities. So the critical activities cannot be delayed. The other activities which have the float available can be delayed within their float time. Okay, so for example, assemble tank was having a float of, say, assemble tank having a float of 3 weeks. Okay, so if instead of say 2, it starts at 5, so it is 5 plus 4 is 9. It is same, so 9 plus 6 is 15. It is not going to change it. Okay, so so we have then, after doing these calculations, we found 2 types of activities: critical and non-critical activities. So any doubt about this? Critical and non-critical activities? Yes, do you have any question? Yes. Okay, so this was the activity on arrow diagramming method. So there is a lot of text in these slides. I think more or less it's the same which I have explained it. So you can go through this text over here. Okay, so we have calculated the activity times, and then remember that how I said that you can complete this table. Can someone explain how we can complete this table? So we have this information available, activity number, we have the description activity information available, we have the duration activity information available, and then from the forward pass, we will calculate the earliest start and latest finish time. So we have these 2 numbers available in these 2 columns. From the earliest start time, we add the duration, then we will calculate the earliest finish time. From the latest finish time, we will subtract the duration, we will calculate the latest start time, and then you can calculate this total float time by just simply subtracting latest start, subtracting earliest start from the latest start, or earliest finish from the latest finish. And then in this way, your table will be complete. After completing this table, you will identify 2 types of activity: non-critical and the critical activities. Critical activities will be those activities which will be having the total float of 0. And then this you can show on the activity on arrow diagramming methods. And in the backward pass, you can simply calculate the latest event times as well. Okay. So in this way, you can see that if you perform the forward pass calculation and then represent the results of that forward pass calculations into the table and complete that table, then you can identify the critical activities in the network, okay, without doing the backward pass calculation. But the backward pass calculations only provides you the latest event times for each activities, which may which is not very useful for us, but just to complete the table. Okay. Any questions and any doubt about this calculation? So what is this? Yes.
So the first and the last action will always have the same late time and early time. Is it right?
Yes. Yes. So first event time will be 0, and then the last event time will be we will start from 0 until the end. And then because this is the point where the forward and the backward pass calculations connect. This is the only point which they are connected over here. Okay. So if we want to establish a schedule, so we will take the we will take them as the same values over here. Okay, so to further expand this discussion, so okay, although we have taken the same time over here, so it means that it is in that stage of the project where we are planning. Okay, so in this case we are planning this project, and then we established that the project will take 15 weeks to complete. Then after once we have established that the project will take 15 weeks to complete, then we have to decide whether that 15 weeks duration is acceptable for us or not. For example, maybe there is a deadline from the client that we want this project to be completed in 13 weeks instead of 15 weeks, because these 2 extra weeks will be too late. So in those situations, maybe what we can do is you can start from 13 as well over here, and then go backward, and then try to establish where we want to reduce the duration to meet this deadline. Okay, so but for normal planning and scheduling, what we will take both of these times as same. Okay, over here. Okay, so this is for the normal conditions. Any more doubt, if there is any?
So using this activity on arrow diagram.
Yes.
So this kind of diagram is only used in design stage, right? So for example, in case of bar graph, we can illustrate how the real process is going on alongside with the designed one. But in network diagram, we just use it for design purposes, right?
Yes. Design is another part. Design itself.
Not design, it's just preliminary management, let's say, preliminary planning.
Okay, yeah, now I can answer it. For the preliminary planning, I think it is normally the planners use the bar chart method. For a detailed planning and more accurate planning, the planners use the network method. Okay, so for more accurate and detailed planning, network method is used. So
while using bar graph, for example, we can see the scheduled data, and then alongside with the scheduled data, we can see the actual data too. What real construction process is going on.
We can see, yes, we can see it, but if only bar graph is used, then it is very difficult to perform the network calculations. these network calculations or the numbers are the real numbers. Bar graphs are just like what we want the project to do. But in reality, the bar in this, it is very difficult to keep the logic of the activities. So although we may show something on the bar graph, but if it is not based on the network calculations, it may not represent the true pictures. So for preliminary planning, the bar graphs are used. But bar graphs can also be used as a result of the calculations from the network methods. So there are several approaches. If only bar chart is used, then that may or may not be very accurate method. If network and then as a result, some bar chart will be used, then that will be very accurate.
Yes, just last question. So do construction managers usually modify this network diagram while real construction process is going on? So this is for preliminary case, this is okay. Like they know theoretically what time can the process take, and then do they, for example, let's say this actual case that we are looking at, for example, pumping house, they designed that it will take 3 weeks, but actually it takes, let's say, it takes 2 weeks. And then do they usually modify this diagram and try to estimate the
Yes,
earliest time to
definitely.
finish?
Definitely. Network, yep. Complete your question,
can
please.
Yeah, it can be modified while the process is going on. Yeah.
Yes, completing a regular updating of the network is a part of the construction management or the project management processes. Okay, so once you establish the network, then that and if that network is approved by all parties in the project, then that network becomes the baseline network. So once that baseline network is established, then of course the work starts on the project. Baseline network is established before the start of the project. So once that project starts, then actual conditions, actual progress on the project is input into the network, and then that network is called as the updated network. And then updated network is compared with the baseline network, and then the progress is measured. So definitely on regular basis, this network has to be, should be updated. So, but it depends on the practice. More rigorous practice for this will regularly update it, maybe on weekly basis or maybe on monthly basis, depending on the requirements of the project. All right.
Yes.
So
Thanks.
So all right. Although I have mentioned about the network method, but the method which I have presented over here is the activity on arrow diagramming method. It was one of the first method which was devised in the construction management discipline. But however, in nowadays, activity on arrow diagramming method is seldom used. So the method which you have just studied is now seldom used. In most of the programs, such as Microsoft Project and Primavera P6, activity on node diagramming method is used. And you will find that activity on node diagramming method is much simpler compared with the activity on arrow diagramming method. Okay, but although your effort in learning on that is not wasted, because many of the concepts which are used in the activity on arrow diagramming methods are still valid in the activity on node diagram method. So we will now look at the activity on node diagram method, which is much simpler than the activity on arrow diagramming method. So again, I am going to skip these text so you can read it from the slides by yourself, because mainly to save the time, because I'm going almost very slow at this point. Okay, so here you can see that this is the diagram of a project, although I think I should have drawn it a little bit longer and a little bit bigger for you. Can you see it well? Okay, I think it should be okay. Can you see it well?
Yes, we see it.
All right. Okay, so now I'm going to explain the activity on a node diagram method. Okay, this is different from the activity on arrow diagram method. And so the diagram which you are seeing is the activity on node diagram. Although you can see some arrows over here, but the arrows over here are not representing the activities. Remember that activity on arrow diagramming method, arrows were representing the activities, but in the activity on node diagramming method, the nodes, that is these circles, are representing the activities. And the arrows connecting these circles are showing the relationship between these activities. Okay, so this is the difference between the activity on arrow and the activity on node diagram method. So here you can see that there is a starting activity, clear and grub activity. Okay, so we start from clearing and grub activity. So once the clearing and grub activity is completed, which takes 2 weeks, and the number 1 over here is showing the activity number, and clear and grub is the activity description. So we are representing this activity by a node or by a circle over here. So once the clear and grub activity is completed, we can start 2 more activity, cut and fill activity, and excavate and form culvert activity, which will take like 5 and 2 weeks respectively. Okay, so after cut and fill is completed, we can start the place base activity. Okay, in parallel, you can start construct culvert activity after completing the excavating and form culvert activity. But here you can see that for these
Sorry, you can continue. I'm sorry.
You can see that for this construct culvert activity, it is not necessary to finish the cut and fill activity because there is no arrow between 2 and 5. Similarly, there is no arrow between 3 and 4. Okay, so the arrows over here only show the relationship between the activity. These are called as the precedence relationships. So we can say that 1 has no preceding activity, 2 has a preceding activity as 1, 4 has a preceding activity as 2, 3 has a preceding activity as 1, but 3 has no preceding activity as 2. So 3 has only 1 activity, preceding activity. Similarly, 5 has a preceding activity as 3, but 6 has 2 preceding activities, 4 and 6. So 6 can only start if activity 4 can finish and activity 5 can finish. That means pavement can only start when place base is complete and when construct culvert is complete. So this is how the process works in the activity on node network method. So as you can see that this network method is much simpler to draw than the activity on arrow diagramming method. But of course, in activity on arrow diagramming method, certain other things are much higher. There are some pros and cons of those methods as well. But in most modern software, any of the network diagram which is drawn, it is based on the activity on diagramming, activity on node diagramming method. So we can perform the calculations on the activity on node diagram methods, and the calculations are much similar to the previous one. So here, some of the calculations have been performed over here. You remember that you can represent the activity on node diagrams by the circle or even as it is shown over here as well. Okay. So in this case, these rectangular shapes show the activities, and then different parts of this rectangular shapes will show the different types of information which is calculated for the activity. So we can represent the activity number and the description in the middle. On the top left corner, we can represent the earliest start time. On the top right corner, we can represent the earliest finish time. On the bottom left corner, we can represent the latest start time. On the earliest right corner, we can represent the latest finish time and the duration of the activities over here and the total float over here. And one advantage over here is that we can perform the forward and the backward pass calculations, and we can directly show the critical activities on this network without completing the table. In the activity on arrow diagramming method, we needed to complete the table to show to show for certainty which were the critical activities. But here we don't need to complete the table, and without completing the table, we can easily show that which are the critical activities. So how the calculations will work? Although all the numbers have been shown over here, it would be much better if I could show it here, but I can show you later some examples where some calculations have been performed. But anyway, so we can start for these calculations. We have also the forward pass and the backward pass calculations. So we can always start from 0 over here. Okay, 0, and then 0 plus the duration is here. Okay, so we can look at the duration is here. So we can see that the duration is here. So 0 plus 2 will be 2. Okay, and then 2 plus 5 is 7. Okay, and then 7 plus 3 is 10. Okay, but here we should be careful. Before writing the final answer as 10, we should check the other path as well. Okay, we should check the other path as well. So it will be 0 plus 2 is 2, 2 plus 2 is 4, 4 plus 2 is 6. So from this path it will be 6. From this the upper path it will be 10. So we will take the highest value as 10, and then 10 plus 3 is 13. Okay. Okay, actually I did made a mistake. Actually, what you will do is, yeah, I should, okay, I repeat what I have said there. Okay, 0 plus 2, then this 0 plus 2, the answer 2 should come over here first. Okay, because from the earliest start, we will calculate the earliest finish time of this activity, because this is the finish to start activity. So therefore, finish of this activity will be the start of this activity. Okay, so I will take 0 plus 2, I will put 2 over here, and then I will write this same 2 over here because it is a finish to start activity. Then 2 plus 5 is 7. 7 will come over here, and then that 7 will come over here. Then 7 plus 3 is 10. 10 will come over here. Okay, and then that 10 should come over here based on depending on the checking from the other paths as well. Okay, so we'll perform the same over here. So this 2 will come over here. The earliest finish time of this number 1 activity will be the latest earliest start time of this next activity. So 2 plus 2 is 4 over here. This 4 will come over here. And then 4 plus 2 is 6. And then 6 will come here. So one value is 10, the other value is 6. So we will take 10. Okay, 10 plus 3 is 30 over here. So this will complete the forward pass calculations. So this forward pass calculation, we will calculate the minimum duration this project will complete. So from this, now we will connect it with the latest finish time. Okay, so if it is 13, then it will be 13 over here. So 13 minus 3 is 10. We will put 10 over here. Okay, so this 10 will come to here. Okay, so what I can do is, this is how it goes. Okay, so 13 to here, and then 10 to here, and then 10 minus 2 is 8. Okay, and then this 8, oh sorry, and then this 8 goes here. 8 minus 2 is 6. Okay, and then this 6 should be here. No, this we have to wait it. We have to wait for it. So this we have to wait it. So for example, this 10 comes here, and then 10 minus 3, 7 is here, and 7 is here, 7 minus 2 is here, 5, and then this 2 comes here. Okay, so from here it was 6, but here it was 2. So now from 2 and 6 we will take 2, the lowest value, and then 2 minus 2 is here. So this is how the mechanism of the values will work over here. So it is, you can see that more or less same as in the activity on arrow diagram method, but the added advantage over here is that we can now directly see that which activities are critical and which are not critical. So once we do this forward pass and the backward pass, forward pass, that is like this, and the backward pass. So backward pass is like this.
What about TF? Is it already given? TF.
What about what?
TF, upper middle column.
Oh, yes. So TF. So TF we will calculate after this. So after this we will calculate it. So this we will calculate it. This minus this, or this minus this, any of these values. So 2 minus 2 is 0, 7 minus 7 is 0. 7 minus 7 is 0, 10 minus 10 is 0. Okay, this is 0 also. But for this, 10 minus 6 is 4, 8 minus 4 is 4, should be same. Okay, 8 minus 4 is 4, 4 is 4. So here it is 4, here it is 4. So now we can see that which activities are critical. So this is the critical path. Okay, this is the critical path. Here, this one, this is the activity, and this is the activity, and the last activity. These are the critical activities. However, these are non-critical activities. Okay, these are non-critical activities. So here we can see that very easily we can see the critical path over here in the activity on arrow diagramming method. Okay, I think we should do some more complex examples, and then you will be more confident. But the mechanism is the same. So in doing the forward pass, you will take the highest value. In the backward pass, you will take the lowest value in case it happens. Okay. Yeah. Any questions? Any doubt?
So this is called precedence diagram, yeah?
Yes. So for in the activity on node network diagrams, there are two approaches. So one of this is this approach, and another one is the precedence diagramming method. Okay. So in the precedence diagramming method, we do some one step more. We try to establish the lags between the network. It is activity precedence diagramming is same as this. There are two differences. So we input the lags, and then we also can represent the other types of activity relationships. So for example, here we have only taken the finish to start relationships. Okay. But some types of relationships can be the start to start relationship as well. So for example, if this activity has started, and with the start of this activity, we can also start off with this the other activity. So we can represent, instead of finish to start, we can represent it as a start to start activity as well. Okay. So for representing other relationships and also some of the lags, we can represent it on the precedence diagram. Essentially, it is the same, but with some other relationships. So the precedence diagrams is an extension of the activity on node format that provides for incorporation of lag time factors, as well as permitting additional precedence relationships. So the use of lag time is very useful when diagramming construction project relationships, where activities can often start as soon as a portion of a preceding activity is completed. So for example, you can represent a lag time between the pouring of the concrete and the next starting of the concrete. So for example, you can represent the lag time as a kind of like waiting time. So for after you pour the concrete on the slab, you need to cure it for some time. But during the curing process, there is essentially not much work which is done. So instead of claiming curing as a real work on the project, you can also put curing as a lag time between the network. So for first pouring, and then if you are doing the next formwork construction, so between that formwork for the next floor and the curing and the pouring of the concrete for the lower floor, you can put a lag time of say 4 days to allow for the curing. Okay, so the lag times are also incorporated, or in the construction of a pipeline or in the laying of the pipeline. So you can, once you start digging for the pipeline, you dig for like 100 meter or 100 feet, okay, long, and then that digging operation will continue for the next phase. And then you can put a lag of say laying of the pipe and the excavation of the pipe, a lag of say 4 days. So lag relationships can also be, and if we represent the lag relationships in the diagram, then we call this type of diagram as the precedence diagram method. The basic principles for the calculations remain the same, but with the additional features in the form of the lags or in the form of the different types of relationships. So we can represent the lag times as 3 types of relationships. Lag time can also be represented in the finish to start relationships. That means the start of activity B takes after some time when the activity A finishes. So for example, if the activity A takes 4 days to complete, okay, so it's if the start time is 0, it will finish at 4, and then there is a lag of 2 days. So then activity cannot start, B cannot start before 6 days. So 4 plus 2, we have to add 6. And then if it takes 2 days, so it will finish at 8 days. Okay. So this is the finish to start a lag time. There can be a lag time. The lag time is are often used in the start to start and finish to finish relationships. So for example, if this activity A takes 4 days, and then there's a lag time of 2 days over here. So although activity A can finish at 4 days, although this activity A can finish at 4 days, but activity B does not have to wait for the finish of activity A. Activity B can be started as soon as there is a lag of 2 days is completed between the start of activity A and the start of activity B. So activity B can be started in this case at 2 days instead of like 4 plus 2. So there is a no lag between the finish of activity B and the start of activity B. So activity B will start at 2 days. So if it is for 6 days, so it can finish at 8 days. Okay, in this case, there is a finish to finish lag time. So finish of activity B and finish of activity B. So if activity A is say for 4 days, it will take 0 and then it will finish at 4 days. So now activity B is say for 3 days. Okay, now activity B, there is no restriction on activity B. Okay, so activity B can also start at 0. Okay, but activity B can finish at 3. But on the other hand, activity B should also wait for the finish of activity A. So activity A finishes at 4. So activity B cannot finish before 4. So in this case, you will take 4 days as over here. And accordingly, activity B will start at 1 day only. Okay. So in this case, in this way, the finish to finish time will affect, finish to finish lag will affect it. Okay. So in this case, if you put a further lag of say 1 day, so you can also, it will further affect it. Okay. Is it clear?
So sometimes start to start approach and finish to finish approach can be same, right? Can it be same?
No, there is a difference between the start to start and finish to finish. So that's why they are represented. Depending on the numbers, they can result into the same early start finish times, but their mechanism is different. Okay, so finish to finish affect the finish to finish relationship, start to start affect the start to start relationship. Okay.
Yes.
So yeah, all right. So I think yeah, that's the end of the time. So maybe we will try to finish this topic in the next lesson. And any questions? That's all for